I am glad you're back. You've stumbled across another artificially intelligent hour of Thinking Through Autonomy. Today's episode explains the unfolding AI revolution in commercial aviation and highlights one of its key architects. Now, if you're suddenly focusing on a pilotless airplane flown by HAL 9000, stop there, just take a deep breath. That's not what today is about. We'll be discussing the real story that's behind the scenes of how airplanes and airports and airlines are changing through the use of AI. Finally, and perhaps to either the delight or the chagrin of today's guest, we're going to discuss how his career took him to the beaches of Cannes on the French Riviera, all in the name of AI. That's got to be a good story. Joining me today is Mark Roboff. Most recently, he was General Manager of Transformation for Aerospace at DXC Technology. And Mark is now working on a top secret project that I'm going to try to get him to spill the beans on. I'm not a spy master, so I don't know if I'll be successful. Mark's an industry visionary, and I am not using that lightly, a consensus builder, and a standards maven for using AI in commercial aviation. He has an expansive career at the epicenter of AI, including a gig with IBM's Watson. He's co-inventor on 2 patents covering natural language processing, and he's host of the new podcast, Cleared for Takeoff, which you can find on iTunes. Today's episode is being recorded on March 23rd, 2021. If you enjoy Thinking Through Autonomy, please like us and subscribe to our channel on YouTube or iTunes or SoundCloud, or Spotify for that matter, wherever you are listening. Open the pod bay doors, please, Hal. Welcome, Mark. Welcome to Thinking Through Autonomy and joining us today.
Thank you, Ken. It is a delight and a pleasure to be here and an honor as well, especially given the chats we've had in the past. We don't need to be recording to have fun and to just start riffing for hours, but I'll point out a couple of things in the intro just to get us going. So first,
yes,
I don't really ever think about HAL 9000, but I'll say that for the standards work that I lead in that committee, and I'm sure we'll get into that, I will proudly say our unofficial mascot is Otto, the inflatable autopilot from the movie Airplane.
I know that.
Yeah.
I know that autopilot. Okay.
Yeah, surely we're serious.
That's one of the cleaner lines in that whole movie, by the way.
Well, what pilot can't reference that movie, especially commercial airline pilot can't reference that movie verbatim?
Do you have clearance, Clarence?
Yes. Victor?
Yes. Okay.
So the second thing is, so Cleared for Takeoff is actually going to be changing its name, and that's actually why we've had a little bit of a hiatus as we get some additional support, and whether that's right now it's looking like some good marketing support from our benefactors, SAE International. They did some research. It turns out that the FAA has a podcast called Cleared for Takeoff.
Oh my!
It's active, but it's not published anywhere except for a website on FAA.gov. So you can imagine our chagrin when we didn't find this podcast on our initial research. Cleared for Takeoff has been used by some aviation podcasts in the past that are now defunct. It's used by a podcast in a different language, I don't remember if it's Bulgarian or it's an Eastern European language. It felt okay. We weren't encroaching on that market. But with the FAA and maybe we can talk about search engine optimization for them. But since they have a podcast called Cleared for Takeoff, and because we obviously have a great relationship with the FAA and do a lot of work with them, we wanted to change our name. So the podcast is going to relaunch in early April with a third episode and some revisions to our first two, and then we'll get on a more structured cadence for that. But right now, and listeners, will probably hear this for the first time since we've just made a decision as to the new name. I think it's fair to say our new name is Future Flying.
I cannot wait for that. And can I just admit a bit of professional jealousy? I am jealous that in your first couple of shows you've had Dr. PK from NASA on before I was able to get Dr. PK. And so now I guess I have to look and worry about what you're doing.
Dr. PK is someone we've been working with for a while. He's a good friend. Yeah, his lift, what he's trying to bring to industry is such an interesting problem.
He's amazing.
He is, yeah. And now with this everything being recast under this term advanced air mobility, there's all this extra focus, all this extra attention, all this extra funding. He is very much a man in demand right now.
Absolutely, and I hope someday to have him on. Let's jump into this because we're talking about AI today, and we could probably have about a 3-day long podcast nonstop to go through all the iterations of what AI involves. But I want to start by talking to you about one of your former colleagues, Rob Thomas, who's now Senior Vice President of Software at IBM. And Rob recently said, and this is a little bit of a paraphrase, Mark, just a tad one, AI is additive. It's about giving humans superpowers and automating the task that people don't really want to do in the first place. Is this a good place to start to help us understand the role of AI in aviation, or is there more nuances in this industry? How do you define AI?
That's an interesting question. I would say that for me, I sort of bring a sort of a naturalist's view to the world. So I like classifying and categorizing things as they are, right? And to me, AI is simply a technology distinct from our existing tools, technology, to write software applications, right? When we think about how we write applications on a computer, right? We're all familiar with programming languages. We're all familiar with what it is to code, even if many of us don't actually code on a daily basis or know how to code. Many of us, most of us, especially in aviation, have been introduced to the concept of putting together an instruction set that fits a certain logic that I'm going to feed to a computer, right, that can take that logic and turn it into a running program, right? And AI ultimately, when we look at it as to what it is, it's a different way to write programs. We're not assembling a set of logical instructions. We're assembling data. We're giving the computer the data we've assembled with some high-level directives and maybe some other supporting information on the side. And we're saying, here's what we want to accomplish. Here's the data. Computer, figure it out. Build us that program. That's the way I look at it. So what's interesting now, and this gets back to where IBM has marketed AI, is that the nature of what we can build through this model of building software, very different. I don't want to use the word model because model has such an overloaded term in aerospace. This method of building software being so different than a traditional method of building software than programming allows us to build types of applications that would be very difficult, if not impossible, to build through traditional logical programming. Great example of that is the systems that understand speech and our accents and our languages and can respond to us, right, in our Siri and our Alexas and the other devices that we use. So imagine having to program line by line, word by word, a system that can understand all these different languages, all these different vocabularies, all these different accents, being able to comprehend all that and then filter down to an appropriate response. It would take forever to do what AI has been able to do in just a couple of years. And when we think about especially the type of programs that we're concerned with in the space of aerospace, right, and commercial aerospace, programs that may not necessarily just be about recognizing a language or recognizing a picture or analyzing a piece of data, but being able to understand a complex environment, react to a complex environment, evaluate and decide, right? I think about the OODA loop. Right? That's another classification of a program that that really requires AI to build at scale and at a reasonable cost and in a reasonable time frame. And think about autonomous driving cars. The reason why AI is so prevalent, machine learning is so prevalent in building autonomous driving cars, and again, speaking at this at a very high level. But imagine sitting down and then programming case statements for every single eventuality, right, that happens when you're out driving your car. You know, what's the programming logic for when someone kicks a kickball in front of your car as you're pulling out of your driveway?
Or the trash bag.
Right, or the trash bag, or what have you. What is the programming logic for getting onto the interstates in Pittsburgh, Pennsylvania, where on certain on-ramps you have stop signs before you go and merge with the rest of traffic? It's actually something, it gives me a lot of comfort that there's so many autonomous driving R&D and startup and development work happening there versus places like Phoenix or where I live. You know, Pittsburgh is a challenging environment to drive a car in any sense. You know,
can I just take a pause in there and ask you this? Is there a supercomputer big enough on this planet to understand how to react to a Pittsburgh left?
Yeah.
I mean, come on. I can't even think through a Pittsburgh left, which to our listeners is a left turn on a red light where the other car has a green light and lets you. It's crazy.
My 4 years of living in Pittsburgh, Pennsylvania, I'll admit I've only seen that twice.
Oh.
So, you know, there are all sorts of things that, yeah, but to the answer to that question, no, certainly there's not.
I don't even think I explained the Pittsburgh left. It's unexplainable. So, you know, that all being said, you have written an immense body of work on AI applications, literally from the ramp to the cockpit. As you're surveying the aerospace industry, what occurs to you as, you know, those top applications that we need to pursue now because we have the technology to do it? You know, what are those superpowers the industry needs now?
So it's a great question. Coming from the tech space, selling and providing systems into aerospace, I mean, and into aviation, right? You often tend to look at the industry and break it down by its value chain. Here's engineering, and here's manufacturing, and here is aftermarket sustainment. And, you know, you could pick one of those areas and say, here's how AI is going to revolutionize that area. I actually like that line of thinking because, you know, the alternative to say, you know, here's something that connects it all. And when you sort of get into, we're going to, you know, connect it all, that turns more into an IT discussion. So to me, I look at what's happening in aerospace and aviation right now. There's all this energy. There's all this focus. There's all this money on innovation, on bringing the verve of Silicon Valley into an industry that is historically very conservative and for very good reasons, right? Aerospace rules and regulations, as we say, are built in blood. Very slow. And very hard for new entrants and new upstarts to get into. Imagine coming down and saying, okay, we have a good idea. We're going to create a commercial airliner company and build a 250-seat airliner, to compete with Boeing and Airbus. And no one would do it. But you see at the same time advanced air mobility and all the attention there, and the fact that that's sprouted up as an industry with tremendous momentum, right? There is a need to further bring in new ideas, new entrants, new upstarts into aerospace and into aviation. And we've only, I think we've only scratched the surface in terms of what can be done. What is the art of the possible? So when it comes back to what's the biggest thing, it's how do we lower the cost of development of safety critical systems while maintaining the safety and the assurance and the reliability and dependability of those systems, right? And I think AI is going to do that. I think what AI will bring to the table, not tomorrow, not necessarily even in 2 years when we have our first standard released, but that will be the start, but over the next decade, is a new means to develop aerospace systems where the cost differential for building something that is extremely safety critical, as we'd say in industry speak, something at the DAL A level, your avionics stack, your fly-by-wire system, your power control systems. Today, the cost for building those systems can be an order of magnitude higher than the cost of building a less safety critical system like an in-flight entertainment system. How do we bring those costs down? How do we close that differential without compromising on the safety assurance that goes into the building of those safety critical parts? I think what AI will bring is a realization of closing that differential. And once that differential is closed, then the floodgates open. Then aerospace becomes as disruptable with new ideas and better ways of working and new inventions as we're seeing in other transportation industries and as we're seeing in other digital industries.
You mentioned a couple really important things there. One was the effect of regulation on industry, right? Obviously a challenge for AI developers. And you just touched on this, and I think it's worth going a little bit into, and I'm going to call it the predictability of the aviation industry. Everybody knows pilots do checklists. Mechanics have a maintenance manual that takes them from step A to double Z in a very predictable manner. Now, I'm not, as you know, I am not an AI scientist by any means, but certainly one of the challenges is when you employ these systems, the auditability of that system becomes difficult because you can't figure out how you got from point A to point Z and say, okay, this is how we're going to map it out. And then you come back to an industry that's looking for that predictability, the explanation of why the computer decided this versus that. I mean, how do you confront a challenge like that?
So that's a great question. I think what we're talking about though, and let's be clear. So when we say an AI system can't show you point A to point Z in the construct of following a maintenance manual or following set procedures, if you're flying an airliner and it's do steps 1 through 7 on the QRH or something, I disagree with that. I think AI can today follow a linear process, demonstrate that it's following linear process, right? And demonstrate critically that it's working in the interfaces and the bounds that you've designed it to work. I think what you're getting at, and correct me if I'm wrong, is the broader concept, and I'm happy to sort of explain my views on this, that AI is a black box, that the fundamental inner workings of AI are, as we say, not explainable.
That is precisely what I'm hitting at, which is the relationship between the gigabytes of training data that you have that trains the algorithms and that black box that gives you an output.
Yep.
And that's even going to have us in the next segment talk a little bit about how you take and scrub ethical bias out of your data sets. But it just seems to me that there is a level of uncertainty that not only needs to be explained to the regulators, but you also have to build that set of parameters and those lanes for the AI. So, clearly that's an issue I would think that you're tackling.
It is, absolutely. It's in fact not an issue that we're tackling. It's the heart of what we're tackling. So let's first define what we mean when we say AI is a black box, and let's be very clear about it, because I think this is an area that people often look at, have questions about, in some other form sometimes attack. But before we can have a discussion about it, we have to have a common understanding of what it is we're talking about. So when we say that AI is a black box, what is usually referred to in that, what really is meant is, AI is a broad space of different technologies. And this is a whole other conversation, I'll admit. It is oftentimes not an easily definable space, right? So I like the definition, AI is what's cool, and once something is no longer cool, it's no longer AI. And I mean that.
All right. All right.
So what we're really focused on when we talk about explainability and black boxes are machine learning, right? Machine learning techniques, particularly with neural networks. Now that's when we talk about AI. The reason we go immediately to AI as a black box, or the reason we go immediately from AI to machine learning with neural networks, is because it's that aspect of AI that has people excited. It's that aspect of AI that is going to create transformatively different types of applications, particularly the applications that can interpret what's going on around and make decisions, executive human-level thinking decisions about flying an airplane or driving a car, right? It's neural networks that will lead to autonomous systems. So a neural network is built on the construct of the neurophysical setup of the human brain. And like the human brain, right, we can we can observe how the human brain works. We can observe that we have synapses and that there are neurons firing in our human brain that represent us thinking about the world. But what we can't do is logically connect that neurophysical, physiochemical observation to how we observe and perceive the world, right? That lack of connection also exists in neural networks. So when we talked earlier about, well, what's the difference between AI, or what is AI? AI is a different way to build software. So in traditional software, because we've built traditional software by providing a computer a set of instructions that flow in sort of a certain logic, right? We know what the computer is doing because we know the logic, right? We either built the program, or we can look at the source code and read what the logic is. We can test the logic, right? There's pure introspection in terms of being able to take a software program, decompose it, understand, well, here's the logical framework, here's the logical set of code that built it. We can't do that with AI. Because the same way, what we've built in a neural network is a data structure, right, with neurons and synapses. And that data structure, when you provide an input, produces an output. That output may be driving a car or flying an airplane. But there's no way in that neural network to logically deconstruct, right, how we got from that input to output.
And if I'm understanding you correctly, then we probably really don't need to do that. And if, there are people who insist that that needs to be done, could it be that they're missing the main point?
Yeah, I think that's absolutely right. Because when we sort of look at explainability from that point of view, right, what you recognize is, well, aviation's already solved this problem. So when we take a pilot out on a check ride, which is the tool we use to assess whether that pilot knows how to fly an airplane safely, right? It's the tool we use to assign trust that the pilot can operate that airplane safely. We're not putting diodes to that pilot's head and measuring the neurons and the synapses that fire in that pilot's brain. We are creating tools that work around the pilot that allow us to assess how that pilot was trained and how that pilot performs. And we can take those tools and bring them into an AI world. Now, I'm not suggesting that this is the be-all answer, right? But I do think that there is a good consensus forming that this is going to be a critical piece to it. Now, right, there will be likely some level of introspection that has to happen with the neural network. And then later we'll talk about all of the work that has to come in assessing and assuring the data that is used to train that network. Because that's a huge piece. That's like, well, not anyone can go and create a ground school or flight school curriculum. Right? There are certain principles that have to be taught. Who maintains what those principles are? That's what we have to figure out with data. How do we know we have the right data? But, right, we can see the concept of training an AI with the right level of data assurance and testing the AI with a virtual AI check ride as forming a center for a model that includes introspection, the AI version of the medical exam, includes other bounding pieces, other parts, multifaceted approach to solve this problem without having to do the impossible, without having to change the nature of what neural networks are.
So if I understand you correctly, if I'm a flesh and blood pilot, it shouldn't matter how my brain thought as long as I perform correctly on the task that I'm given.
Right.
It's almost irrelevant to wonder, what went on in that pilot's brain. Just as with the AI, let's focus on the performance. Is that right?
Well, to a degree. So there are all. Obviously, when we look at famous air accidents or incidents, we often wonder what went on to that pilot's brain. Of course, there are levels to where we can interpret that, right? And there will be similar levels to how we'd be able to interpret that with AI. I look at that. I often think about the Germanwings incident where you
horrible,
had,
absolutely horrible,
absolutely indeed. And we say, okay, well, the pilot was depressed. Right? Well, we don't know what the pilot was thinking. We didn't, again, wire up diodes to that pilot's head, but even if we did, we'd have no way of looking at the physical workings of that pilot's brain and say, well, this pilot shouldn't fly anymore. So we have to be able to assess at a higher level, and we can do that with AI, right? And that's part of the strategy. But to say that AI certification is impossible until we make neural networks completely explainable and completely logically interpretable, I don't think that's the answer.
Oh, I wasn't suggesting that. No. I hope not.
No.
So I just, before we close out this segment, I just want to hit one other thing that we touched. And that goes back to the idea that these AI systems are based on data sets that we train algorithms off of. And anybody who looks at the newspaper will see all the issues Google has been having with their AI ethicists. We understand that in the emerging field of facial recognition and biometric recognition, that there's a real concern about biases built into these data sets. And when you look at a industry like aviation, which is as international of an industry as there probably is, there are different cultures, there are different languages, and just go through the permutations. How do you ensure that as you're building your data sets, that unintentional bias doesn't accidentally leak into it?
Now that is the question, isn't it?
That is the question.
That is the question. So I look at unintentional bias is only one thing we have to solve for. The biggest thing we have to solve for is understanding what the right scope of data is to train a model, to train an AI system, right? And the industry, I would argue, has some very good practical lessons that it's learned through where it's been applying AI and big data on the airplane over the last 10 years, at least where it's been attempting to, and that is in predictive maintenance. So my background in terms of rising to lead the industry standards effort for AI, for aerospace, for aviation, it didn't come out of nowhere. It came out of my work primarily in MRO and with predictive maintenance systems, working on predictive maintenance systems at Airbus and at Honeywell and with airlines all over the world. And what we learn is that, first and foremost, you never have as much data as you'd like. Particularly in commercial aviation, that's an entirely other subject. But oftentimes, even if you had all of the data that you could ever ask for that may be coming off an engine or that may be coming off a bleed valve or something, that alone isn't enough. There's a good question out there. I could have petabytes of engine vibration data.
That sounds like a lot.
It's a lot. It's a tremendous amount, right? A tremendous amount of engine vibration data off, pick an engine, but any
CFM56.
Yeah, I could have the world's repository of CFM56, right? Vibration data, the Airbus version, the 737 version, even the retrofitted CFM56s flying on old 707s and DC-8s. I still probably won't be able to get to a critically useful predictor because I need more than just the engine vibration data. I might need air quality data. I might need weather data. I might need pilot performance and FOCA data. And good luck getting that from the unions, right? I might need even ground data around the airports and a whole host of flight history. Understanding what the data space is a critical question. And building assurance models to that's an area where we're focused, and we're working with EASA and the FAA and other leaders in the space to figure out a model to answer that. Ethical bias comes into that question as well, right? Data is a representation of life. Life tends not to be fair and ethical and equal. So we have to be mindful when it's a critical requirement, as it is in many AI applications, to account for that, to engineer for that, right? One of the more interesting things we're working through right now is, in traditional aerospace engineering, it's so much of the success or failure of a project comes down to the requirements and how those requirements are managed through a validation and verification chain. And one of the things that we have to and are working to figure out in this new world is, what do data requirements look like? And how do data requirements play in a traditional aerospace validation and verification chain? Or, right, do we need a new type of validation and verification model that better fits AI? So those are some active questions that the standards boards with regulators are exploring right now.
And I want to hit that particular subject in just a little bit.
Sure.
But first, I want to talk about being Mark Roboff. Okay? I want to talk about being you. Because growing up, I understand that there are these influences in your life that made you the kid asking for model trains and cable cars and trolleys as presents, and not necessarily airplanes like the rest of us. And I hear that your grandfather was an electronics enthusiast, your father is a train enthusiast, and your favorite museum growing up was the Seashore Trolley Museum in Maine.
That's right.
And the people who know you best say all of your passion involves transportation, and it started there. So tell me about your memories there and how that museum turned you into the AI maven that you are now.
I don't know if it was that museum. I grew up in New York City and right outside in suburban Westchester County, and loved trains as a little kid. I had when I was my son's age, he's about turning 4. I lived in an apartment in downtown Scarsdale, New York, overlooking the commuter rail tracks, and I would, or at least I'm told, because who remembers things from when they were 2 or 3. I would spend my afternoons glued to the window watching the trains coming by. So that's what seeded, I guess, an interest in that. And I remember going up to, even in 2nd grade, when my teacher asked all of us what we wanted to do when we grew up. I said I want to run New York's MTA.
Okay, that is great, but that doesn't explain how you wind up in the aviation industry. So you should be head of WMATA, head of MTA.
Maybe. Well, so I'll tell you how I got out of wanting to do that and how I got into aviation. So then in 9th grade, my mother bought me a copy of Robert Cairo's The Power Broker, and I read through that and I realized 2 things. What I really wanted to be with Robert Moses, and not president of the MTA, and that the last thing I wanted to do was run that organization, because the funny thing about that organization and transit agencies in general is that they're designed for people. Let me rephrase that. So they're designed in part, I say this somewhat tongue in cheek, to prevent people from single-handedly shaping transportation. Right? They're designed to prevent people from, like Robert Moses, from running amok in cities ever again. It's funny. It's why the MTA, the organization that runs the New York City subway and the New York City commuter trains and the New York City buses and the New York City bridges, is not a New York City entity. It gets its power and reports to Albany. But I digress. So I've always loved aviation. It may not have been at the center of my childhood, but when I fondly look back at where I was always happiest or most excited about things, it was always when I was getting on an airplane, going down to visit relatives in Florida, or I remember my first international trip to London when I was 10. And my passion for aviation matched my passion for trains. I would always know, even when I was 4 or 5 years old, what type of plane I was flying on. I always had to have a window seat, right? There's 727s and L-1011s, which was my perennial favorite growing up, right? I remember, again, at 10 years old, vivid memories of and my father shares this passion a little bit, of being passengers on one of the first MD-11s, and doing a Cat 3 landing in fog at Heathrow, in the dark of night, because we took that
old Autoland.
The old Autoland, right? Yeah. And being very impressed with the MD-11's capabilities, which I guess back in, this was 1993, 1994, right? Before I think the world had a good understanding of what the MD-11 did well and did not do well. Right. So I've always loved flying. I've always been technical. I've always been very passionate about aviation. But what really drove me to say I want to dedicate the rest of my life, my career to this field, was when I got into my professional work life and started traveling a gazillion miles a year, and started thinking about just how much time I spend on planes and my fascination with it, my love of it, and wanting to interface with that and impact that world. Right?
And you are, and you have been.
I hope so, in a positive way.
In a positive way and a demonstrable way. Let's move a little forward in your life, and I want to talk about Watson.
Sure.
You are an alumnus of IBM, and you were there in 2011 when Watson trounced two of the greatest Jeopardy players in history. And let's start talking about what's the environment like at IBM on that fateful night. I mean, are you guys having Jeopardy parties, or is this like JPL and you're waiting for that 7 minutes of terror to happen and you don't know if there's going to be a crater or a rover on another planet? Tell me about IBM, or wasn't it a big deal, Watson?
No, it was a very big deal, and I was still relatively new at IBM, but already engaged in a part of our software suite there. I still say our part of IBM's software suite that made up the Watson technical stack is very much the former. It was Jeopardy parties. Everyone was really very excited. It was a huge splash. There was a lot of confidence in the organization that we would make a huge mark on the world. It was sort of the next big bet. Everyone was comparing it to Big Blue, which was the chess computer that beat Garry Kasparov in the 90s, and it started quite a journey for me and for international business machines when it came out and did what it did.
And what it did was impressive. Let me just dig into a couple details about Watson, and then maybe end up and say, well, how come we're not hearing more about it today? I mean, I've read about Watson, and clearly the focus on that system was natural language processing. And one of the, on something that impressive, you can't say one of the weak points, but one of the realities was it didn't do structured data like numbers and images. And I get that that's, 7-8 years ago now. But as the field of AI has progressed, are there AI systems that can merge the data with the language and come up with intelligent conclusions about what it's processing? Or did I just talk about two separate specialized machines there?
So, good question. Very good question. I'm trying to think about how I want to answer this in as clear a way as possible. So I'm going to say two things. So when we talk about Watson as an AI machine, we again hit the issue that AI is a very broad term, right? And that was some of the challenge we had, is when we defined Watson as being able to do AI, as Watson being the AI machine, where in fact it was really focused, as you mentioned, around natural language processing and providing huge advancements to the state of the art in terms of semantics and semantic processing. Right? I think that some of the stumbling we had was expectations on what it is, what it can do, weren't necessarily set as precisely as they should be. So AI, broadly works with all sorts of data, right? AI can work with structured data, AI can work with unstructured data, AI can work with visual and auditory data. But when we think about Watson as a semantic processing system, right, natural language processing system.
So understanding speech or words.
Exactly.
Yeah.
So it is a challenge, and it is still it is not to my knowledge, and I was actually looking this up recently. It's still not a solved problem. Being able to have a semantic processing system like Watson correctly reads the easy part, but correctly read and then interpret data from structured sources that are intermixed, right? That is not easy to do, and it is not yet a solved, ubiquitous capability. So, for instance, right, think of a airline or airplane maintenance manual. an airplane maintenance manual might be prose, unstructured text. But is it really? It's even though it's written in English, and there's paragraphs and smaller paragraphs. Really, it's highly structured, unstructured text, right? It's a list of steps. It's a list of conditions. If you see this, do that. Otherwise, skip here, right? And at the bottom of a lot of maintenance manual or fault isolation tasks, there's data in tables. This is the type of content where semantic processing systems still today stumble.
Let's circle back to one of your, I want to say passions, because I think it is, and maybe what you're best known for, and that's SAE's G-34 Aerospace AI Implementation and Certification Committee. And thank God that's got the short name. Okay,
that's right, because and we have to also mention that we are a joint international committee with EUROCAE Working Group 114. But that's the world of standards.
I appreciate that, but my semantic search did not allow me to add more data fields than
fair.
That. So I went for what I thought was maybe shorthand. But anyways, you are leading 500 of the top aviation professionals in the industry, looking at the future of AI and looking for standards for AI. And I've got to ask you the basic question, okay? And we touched this a little bit, but really, why do we need standards? What's a standard going to give us that we don't have right now? What's the end product of all the work you guys are going to do?
So why do we need standards? I'm thinking about the best way to answer that question. I'll give a tongue-in-cheek answer because I think it really does hit it right on the nail on the head, and then I'll give the diplomatic one. So I frequent in my sort of daily internet reading a Reddit-like bulletin board called Hacker News. It comes out of my startup days and something I've kept with me at big companies and small. It's a website that's produced by a very famous startup incubator called Y Combinator, and I read it because I like to keep a pulse on what is the current hubbub coming out of startups in Silicon Valley. And there was a post a couple of weeks ago, had nothing to do with aviation, had nothing to do with aerospace, but it was a post from someone who is complaining about standards, IEEE standards and ISO standards, and complaining about how you have to pay a lot of money to get the standards, right?
And I worked for an organization that made you pay too, so
indeed,
go ahead.
Yeah. And it was questioning what good these things were when everyone aspires to open source software development, and Silicon Valley aspires as a whole to be able to do things faster, more cheaply, and to have more freedom to go, right? And sort of the best comment is that standards are laws that no one tells you about until you learn about them, and then you have to go pay to read what they are.
And comply, or your product doesn't go to the market.
Correct.
You're not making any money.
So, in a regulated industry,
right,
where such as aviation, where the regulators say it's important that we maintain a safe environment, it's important that we maintain a regulated environment, but we want the actual criteria for what is safe and how safety is demonstrated to come from industry, right? And not have just us regulators at the FAA or EASA or Transport Canada or CCAC or wherever, right, dictate them to you. Well, the way that the industry conveys those specifications, conveys those requirements, are through standards. And in aerospace, right, what an engineering standard really is in many cases, and critically in our case, is a means of compliance, right? So if you want to build an airplane to have all these advanced features like fly-by-wire and an avionics stack, right, glass cockpit, all the things that we've taken for granted in the world of commercial aviation circa 1985 and onwards, you're going to need to comply with these standards that take you through how to, from a performance standpoint, from a performance requirement standpoint, and yes, in many ways, at the very least implicitly, if not explicitly, from a methodology standpoint, right, you're going to have to demonstrate that you adhere to these requirements. So it's sort of, I sort of like that definition somewhat. It's like these laws that you don't know about until it's too late, and then you have to pay to actually read what the laws are. Because if you don't follow it, you don't bring something, you don't get to bring your good to market.
And the corollary that I run into in my own business is this. I have companies approach me and say, "We hate that standard, go get it changed." And you're like, that's not going to happen. You could pay me, but I could tell you I'm not going to be changing an SAE standard so that your business model is, somehow taken into account of. That's not something that happens after the fact. Yeah. Let me ask you, in terms of standards, as you look at the work product for the committee for 2021 and 2022, what are the committee members telling you are the things that the committee needs to flesh out more, what's the work product look like over the next year or two?
Great question. So the work product right now is building a first generation, I'm going to call it a first generation aerospace standard that we hope the FAA and EASA and Transport Canada and ANAC down in Brazil and all the other regulatory agencies that are working with us will adopt as a means of compliance for AI systems. Now, that is not going to bring about the concept of the virtual check ride. It is not going to bring about the concept of you treat an AI autonomous system like a human pilot. And the concept we talked about actually has a name. It's called AI licensing. It's fun. A lot of people have come up with the concept over the last few years in independent settings and forums, but the article or the white paper that I point to that really describes it in the best detail was written maybe 6 years ago for NASA by a technical fellow at Collins with a technical fellow at Honeywell. I want to double check that because I think that's correct. I have the white paper in my drawer. But we need to start somewhere. So the first standard is going to address validation and verification in an AI lifecycle. It's going to address the overarching high-level principles of how we might solve for explainability over the long term, even if it won't necessarily take an applicant who's building the inflatable autopilot, to certification. That will come in time. It will address simpler levels of machine learning, and it will address the fundamental questions and requirements around data assurance, which we talked about. I'm also hoping, and this is something that I've been building towards with the committee and its leadership lately, it'll address simulation. Simulation's a really key piece of how we intend to verify AI neural networks, trained neural networks. And I'm not talking about physics simulation systems that aerospace engineers use.
This is not Microsoft Flight Simulator or the pilot simulators, correct?
It is.
It is.
It is. Okay. So I'm not talking about things like Simulink or MATLAB. I'm talking about Microsoft Flight Simulator, right? Okay. So full flight simulation is a critical tool. And it's funny you mentioned Microsoft Flight Simulator or X-Plane, because when you look at all of the autonomous system R&D that the industry does, R&D, mind you, not necessarily commercial product development, they're done in systems like Microsoft Flight Simulator and X-Plane. Right? That's where they all start. I've worked on a couple of projects in X-Plane and in not the old Microsoft Flight Simulator, but Lockheed Martin's Prepared 3D.
Yes, know it well.
Right, which actually
never ran on my computer, but that's another story.
I was listening to your podcast last night with Stella Widener, who I've come to know, And you mentioned, what can I go to buy from the Boeing company if I go to Boeing.com? I laughed at that because you can go to LockheedMartin.com as an independent, URI and go buy something and get a receipt from Lockheed Martin. Prepare 3D, for folks who don't know, when Microsoft Flight Simulator sold, and this is not the brand new one that just came out in August, which is an amazing platform. But the old platform that was developed up until about 2005, 2006 had always this commercial version that was used in advanced training devices and other systems. When Microsoft shut down the studio for the old Flight Simulator, Lockheed Martin bought the IP for the commercial version, modernized it, and continues to sell it today. So I'm I've been a long time prepared 3D fan. But anyway, yes, it's those systems that people are using to explore the world of autonomy and aviation. When we think about the concept of the virtual check ride, when we think about the concept of how we will evaluate these neural networks, these AI systems we build, before we even think about how we implement it onto the airplane and begin the old fun traditional flight tests that cost so much money, right? We know flight simulation is going to play a huge role. Now, it may not be that we go to CAE or to Thales and buy our level D full motion flight simulators, right? But we need the ingredients that go into that, right? We need the virtual world. We need the binaries, the real binaries of the real fly-by-wire systems and the avionics systems and the power control systems, right? Which we then connect to that virtual world, and then we need to put the AI systems on top of that, right? And then we need to have a platform that allows us to write and run tests. Now, the really cool thing is that if we can define this environment that we can look at and say, this is so robust, this is so accurate and reflective of real life that we could use it as a facsimile for real life. That's where we talked earlier about reducing the cost of safety critical system development. That's going to be a major driver of that, right? Because what used to be done physically in the physical world can now be done virtually, right? In a virtual world, in a extraordinarily accelerated time frame, at an extraordinarily reduced cost, right? And we can also leverage the power of computers to test for many more cases and many more scenarios than we'd be able to do in real life. So flight simulation is again, it's that next piece. So that's where we've been focused now. Well, whether that makes it into the standard and that we're due to produce in the next year and a half or not is TBD. But it's going to be what we focus on right after, along with AI licensing and explainability and all the ingredients that will get us to the autopilot.
So when we talk about standards, and just in this conversation of the past, half hour, we've talked about some incredibly technical issues. We've talked about some incredibly brilliant people who are doing this work. And certainly there are companies that are under great competitive pressure to break into this marketplace. So you put your chairman's hat on for a second, and you have these 500 passionate people and companies around you. Can you share with the audience, how does something become a standard? Are you taking a vote, and if it's 51-49, it becomes a standard? Does it have to be like some organizations, 100-0, everybody has to agree? How do you figure out when you put the gavel down and say, metaphorically, this is the standard? How do you measure that?
Great question. So a standard is, I think, most everywhere, if not everywhere, and if not by definition, a consensus-driven document. So when a standard is released to the public, know that it has reached the consensus of the committee. So different standards development organizations have different processes for demonstrating officially that consensus has been reached. But it is not simply done in the confines of a single isolated vote. Although within SAE and within EUROCAE for the standards, not for every single document, but for the standards, there's a voting process, right? Consensus is achieved over time, all right, and day by day in the committee meetings and in the subgroup meetings and in the working groups, piece by piece, right? And really the success of a committee is in its ability to facilitate the necessary dialogue and discourse in the right context, in the right environment for consensus to be achieved. And that's what I'm most concerned with as chairman. So, I have an engineering background, software engineering background, right? I've never worked professionally as an aerospace engineer, although having taken this role, I'm now quite familiar with the standards and the worlds and the processes of aerospace engineering. But the value that I and my leadership team brings to the table is not that we're solving all the technical questions or even contributing that much to the technical content. Now, we're stewards of the organization. We have to make sure that the standards we have to make sure that the committee we run works well, that the people in it work well together, that discourse is flowing, that dialogue is allowed, and that we're guarding and fostering ever so the environment for people to build consensus.
So, Mark, in my introduction, I kind of mentioned the French Riviera, and you were CTO at Orpheus Tech Music Licensing. And when I found out about that, because it's on your LinkedIn page, I kind of scratched my head and I said, that seems to be a career detour from your roots at Carnegie Mellon. Living up in Pittsburgh, being close to Carnegie Mellon, having friends that are on the faculty there, I kind of had this perception of what a person pursues after they work on AI at CMU. And I saw that and I just kind of was scratching my head. And I'm told by people around you that there was this really fascinating technical challenge on a platform under development. And you weren't necessarily attracted by the allure of the music industry. I'm thinking, isn't that backwards? Shouldn't it be, you're attracted to the music industry and the glamour around it? But actually there's this challenge. Can you tell us a little bit about that technical challenge that, kind of brought you off on that detour?
It's more of a business challenge than a technical challenge. And I love the music industry. I'll explain how I got into that and how maybe that helped me get into aviation. There are some spurious links. So after I graduated in 2005, I had a couple of different opportunities that I was looking at, right? One, which was very common with folks who graduated my university in 2005, was to go into the world of finance. This was post-dot-com boom. This was the big, let's all go make a ton of money in financial services. This is before financial services has now resurged a little bit as fintech.
And that's the path for CMU students.
Yeah, well, yeah. I was interviewing with Wells Fargo and going into their leadership development program. And the program was structured as such where they were going to put half the people they accepted into San Francisco, which is where I really wanted to end up, and then the other half into Phoenix, really Chandler, Arizona, which is a suburb of Phoenix.
Okay, I get that.
Right, and you can guess where they wanted me to go.
Yeah.
And I said no, thank you. Now, of course. Right. Here we sit talking 16 years later, and Phoenix is a quick hour flight away. I've spent a great amount of time there. I have a great many friends in the Phoenix area. Of course, Honeywell Aerospace is based there. So I've ended up getting to know Phoenix well, regardless. But because I turned down that position, I started looking for things locally, and what came up at the time, this is a first job, was a software developer at a small stock photo company. So my first few years in cutting my teeth in software engineering were in stock photos. And as I was learning about the business of stock photography, what really puzzled me was that the value of a stock photography license is not in any way connected to the intrinsic value or the worth of the picture. It's connected entirely to how that picture is going to be used. Right? And the digital photography revolution, I still remain an avid photographer, has had created all of these new models in stock photography around crowdsourcing, because now anyone with talent can now access the tools, and the production workflow has been revolutionized by digital SLRs, right? Where the whole industry is being upended. So my aunt, who is based out here in LA, who is a very successful country music songwriter. If you know the song "This Kiss" by Faith Hill,
I've heard of that. Yes.
So she wrote that, a whole bevy of other things.
Okay.
She was my connection into the music industry. And in music industry, right? What attracted me to the business of the music industry, again from a licensing standpoint, is you don't have that same issue with stock photos. In fact, the price of a license is tied inherently to, right, the worth of a song, the cultural worth of the song. That's sort of how the music industry revolves. So without getting into too much detail, the business challenge and the technological platform that we were building to solve the business challenge was that there are several different types of music licenses that drive several different types of playing music, right? There's a type of music license that you'd get if you were to buy a CD. There's a type of music license for when you're playing, if you're the owner of a pub or you're the manager of the pub and you put on music on your pub. Well, there's a type of license for that.
Is there a license for a dopey podcast like mine?
Well, you're getting to that, right?
I am paying for this, folks. If you hear the music at the beginning, I am paying for it. But I digress.
So then there's the license for using music in film or TV or radio. That's called a sync license. So, in the other two types of licenses, there are companies that, through their history in the industry, became sort of de facto facilitators of those type of licenses. So there's this company. I guess I haven't been involved in music in well over a decade. So with everything moving to streaming, I'm not sure what they do today, but historically there was a company that managed all the licenses for CD production. It was called the Harry Fox Agency. Okay. There are a couple of companies that manage the use of licenses for public performance, bars and restaurants. You may have heard of a company called ASCAP, right?
Never.
Or
sorry,
BMI.
Not my world.
Right. For sync licenses, there is no facilitator. There is no process to manage holistically at an industry level how licenses could be, or how music could be discovered for sync, and how those licenses could be brokered and negotiated. So what Orpheus was an attempt, via building a digital platform to become that facilitator. We would have a storefront. It would look a little bit like iTunes. You would have music producers and music supervisors who work on films and advertisements and shows come to this storefront, discover music, right? And then our back-end system would help facilitate a negotiated license, and we'd take a cut of that. And the value to the rights holders was automating that process, which till then, maybe still today, happens off paper and fax machines and disconnected ad hoc systems.
Okay, and you have to answer this question for us. So you walk into your boss's office and you say, "Boss, I need to go to Medim and Khan." And the boss says, what, I'm not sending one of my AI gurus there? Or he says, go ahead.
Well, the company was 3 people. It was myself and 2 co-founders, right?
Okay.
And it wasn't my idea to go to. It was meet them. It wasn't my idea. It was my co-founders, because they came from the music industry. They said this is going to be where we go and hit it big. I will never forget that conference, because getting there was somewhat disastrous and really, I think tripped me up, and I don't know if it was why the company didn't work. I mean, there are confluence of factors. It was still very soon after Napster, and it was still when the industry didn't trust digital. But
yeah, I mean, I have to think that, with Napster being founded and big in 1999 and 2000, you come on the scene, there has got to be debris all over the music industry regarding Napster.
Yep, and navigating that was a challenge. But I'll tell you, because it's an aviation story, what tripped me up for Meetum was the flight over.
Yeah.
JFK to Nice, which Delta has run for ages and ages. This was, I get there, I'm young, not too long out of college. This is before I understood the world of business travel and how to succeed at frequent flyer programs and upgrades, and it's before I knew any of that. So it's just a guy in seat 36F. So I get to JFK. This is the old Terminal 3, the old Pan Am Worldport. There's this little bistro in the center of that round rotunda part of that terminal, and whatever I ate gave me food poisoning.
Oh!
And I had probably the most miserable flight of my life, flying on a pre-renovated Delta 767 with no seat back IFE. It was just me, the seat in front of me, and my barf bag, and 2 seatmates on either side. I was in the middle seat, right, who were very displeased with what was going on. And I was sick for a couple of days, and it was hard to recuperate from that. That taught me a lot about how to fly successfully, right?
Well, and that sounds like an inflection point. I mean, if you were the model of health when you landed in France, you might never have come back, and we might never have seen you in the aviation industry.
Maybe. It's funny, I've actually been back and I've done more work in that area. Yeah. IBM used to have a office up in the hills north of Cannes, in a town called Lagode. So I've been back. The funny thing about Orpheus is that it's inspiring a lot of work I'm actually doing today outside of the AI engineering realm. The other area that I have done a tremendous amount and continue to do a tremendous amount of work in is MRO, especially digital in MRO.
Which would be MRO, meaning maintenance for the airline industry, right?
Exactly.
Fixing planes.
Maintenance, repair, and overhaul. So I mentioned that where I cut my teeth in AI in this industry was in building predictive maintenance systems and designing predictive maintenance solutions for airlines. And it's a great field, lots of interesting, fascinating, complex technical challenges to work on. The biggest challenge to work on of which is to figure out how to get airlines to pay for predictive maintenance.
Oh, good luck. Okay.
All right, and today, where I and a few friends are focused, not on predictive maintenance, but in, just like with Orpheus, facilitating data across an ecosystem. So when you look at some of the challenges in just the operations of airlines and their supply chain, right? Yeah, it's not just within an airline, but it's how does an airline interact with Boeing and Airbus and Honeywell and Collins and Zodiac and all the different customers that make up the supply chain. So I don't know if you've ever had it's always fascinated to me that buying an airline is not like buying an airplane. If you're an airline, it's not like buying a car. It's like buying a house. If Toll Brothers builds you a house, they're not going to maintain your refrigerator. So you, as the homeowner, need to have a relationship with all of your vendors.
Some horrible insurance company somewhere. Yes, but that's something else.
So the world of facilitating data across that MRO supply chain is one that is very manual and very inefficient. And there's a tremendous opportunity with the right folks to facilitate a platform that can digitize that and drive upwards of $33 billion of value to all of the stakeholders in that MRO ecosystem. So this is where we're talking about things like federated systems of records and blockchain, and how do you take a part and have a perfect representation of that part's history, its flight hours, its maintenance records, so that when you need to calculate the remaining service life of that part, you can do that instantaneously, automatically, and at extremely low cost. And also be able to, because you have all the data in one place, you can now have a much more accurate read on the remaining service life of a part, that in many cases increase the value of a part. And that could be an immediate revenue recognition opportunity for a part holder. So when we think about facilitating the build of this system, there's a very good time to do it, and that's right now, right? Because we have COVID, we have an industry that's been very hardly hit, and we now have the industry that's going to look at now recovering. If we can build a system that can facilitate across the ecosystem all of this data flow, we can take a tremendous amount of cost out of the business of doing the recovery.
Now, my crystal ball says, and I don't have any good reason to say this, but it sounds like you're a man who's figured that out already, or at least major portions.
Yes. And
that's the next podcast, right, Mark?
That'll be the next one. I'll say that it's not so much figuring out the technical hires how we're going to do it. It's about assembling the right group of people, the right musketeers with the right level of experience and connections in industry and leadership in industry to get everyone at the table, build consensus on how we're going to solve the problem, and facilitate a solution.
And I'm looking forward to next steps in that. So as we are coming to the end of our hour together, actually a little bit more, I just want to ask you about something that was related to me, about some of your hobbies or one of your hobbies. So
Sure.
When I think of Mark, I think of this guy who can command the attention of the largest supercomputer in the world, right? Whether it's Watson, whatever it is, you're the guy who feels comfortable in that world. Yet I understand you're a bit of a hardware hacker yourself, that you build your own computers and you show off your own computers to your family. Tell me, what is in this latest build? I think it was last month. What are you doing with it, and what kind of hardware is in there? I mean, are you trying to build your own supercomputer or do Ethereum mining, or what the heck?
Funny you mentioned. So I was just looking at Ethereum mining.
Hey, that was my crystal ball working. Okay,
there you go. So yes, I used to, and now once again do, thanks to COVID and being grounded for a year, have a hobby in building very high performance, very customized computers. Back in the 2000s, I would shop around for different batches of the same CPU, trying to find a batch that I could competitively overclock.
Okay.
Which is a thing, which people do.
Yeah, you're speaking my language.
And back then it was, perusing the right bulletin boards, right, online, the right websites with the right forums, and reading batch codes off Intel Core 2 processors and sort of swapping around, right? That's when liquid nitrogen just became a thing. I never quite got to dabble in that, but would build these highly complex custom water cooling loops before they became in vogue, I suppose. Today, those forums are largely gone, and the industry of that hobby centers around a couple of key YouTube channels. But it's been nice to get back into it. I built a computer in 2010 that at the time had sort of the best of everything. I had just started with IBM. That's where I really started traveling upwards of 200,000 miles a year. Loved the out and about life, and that computer that I built in 2010 served me perfectly fine up until last August. And then because at a certain time, 10-year-old componentry that you use every day, right, starts to degrade in its performance and its reliability. And because I was grounded, and because I needed something to do to take my mind off the misery of is the whole world collapsing, I said it'd be a great time to build a new computer. And I carried forth the same philosophy of last time, and also said, okay, all the work we're doing with standards, and standards, by the way, it's all volunteer, so I'm not getting company equipment, nor is anyone else getting a company equipment, to do proof of concepts or tests on. I said, well, I can go the extra mile here and justify getting the best of the best, and it'll last for another 10 years. So today, and I'll show you a picture of it with my webcam here.
We'll post that on the show notes page.
Sure.
Get a nice, wonderful picture.
So
it
has all lights. Lights for me are like 3D televisions back in the 2000s. If you want high-end equipment, you get the lights, whether you want them or not. Just like if you wanted a good TV 10 years ago, you got 3D, whether you want it or not. But the CPU is a 24-core CPU, which is, I would say, 18 more cores than my last CPU.
All right.
It has 128 gigabytes of RAM. I remember back in the 90s when 128 megabytes of RAM was an amazing thing and bleeding edge.
Well, do you remember 128K?
Yes,
I
do.
Yeah, that's okay.
I remember when, having
we're
4
two
gigs,
guys
you were
here
the
going,
cock of the walk.
Yeah.
The crowning achievement is probably the video card.
Please, I saw the letters RTX. Please don't tell me it's 3080 or 3090, because I'm going to cry to end this episode.
It's a 3090.
How did you do that?
So I'm not going to say, but I will say that I got it at list price, and I didn't have to use a scalper.
Look, you want to know what I did? I logged in. I got to the NVIDIA website, actually for the day that the 3080 was launching. And I started clicking my cart almost 15 minutes before. Boom! I get the RTX 3880 in the cart. I've had my account made already. Yeah. And by the time I get to put my credit card number in, it's gone.
I tried that too. I had that experience as well.
I'm going to say something bad about crypto miners, but that's
so that's not what's driving. I mean, it's an incredible issue right now. So it's a little bit of crypto mining. I bought this for AI.
Yeah.
And for Flight Simulator and for some other games, but mainly for AI and to make it available to my team at SAE. And it helps that I have, again, friends at NVIDIA who work with me on this subject. But again, I'm not going to say how I got it. What is so fascinating right now is, yes, if I wanted to part with the card, I'd sell it for like double what I paid for it. Some other cards are going for triple, which is insane.
It is.
But it's not crypto. Crypto's an element. There's a huge shortage in silicon manufacturing. It's a huge supply chain issue. It's quite fascinating. I've heard all sorts of different things as to why. I think right now people just say it's just supply and demand. It's frenzy. It's everyone who would typically order, large enterprises, right, who would typically order 3 to 6 months of inventory got spooked, like with the toilet paper scare back a year ago, and started ordering 3-4 years of inventory, right? But and then I heard, this is interesting, I heard when I was building this back in August, so this is before we had the huge perverse supply chain issues with hardware that we have now. But at the time, for everything else, but the 3090, I picked up at my local micro center, which is now the only real computer store in California now that Fry's has finally given up the ghost.
Say it ain't so.
They've been in zombie mode for the last few years.
I did not know that. But then again, I'm living in North Carolina, so I wouldn't.
So the CPU and the RAM, the motherboard, and everything else came from Micro Center, except for the GPU, which I got later. But the only thing back then that I couldn't get was the power supply. So there was a huge power supply shortage. Now it's a huge everything shortage. And what I was told at the time, I thought was really fascinating, was the issue, and I don't know if this is true or not, I just thought it was fascinating. And I've sort of tried to research this and can't corroborate the story, so maybe it's not true, is that it wasn't necessarily that anyone had trouble making power supplies. It was the preferred mode of transportation from power supplies from China, where they're made, to the United States. It's not on cargo over the ocean. It was not necessarily even on FedEx or UPS planes. It was in cargo and passenger aircraft.
Okay. Well,
right? Because United has United Cargo, American has American Cargo, Delta has Delta Cargo, Air China has Air China Cargo.
Pacific, fill out.
Yeah. So apparently all these power supply OEMs like Seasonic and some of the others had all their contracts with just the passenger airlines, and what happened with COVID? They all stopped flying to China.
Yeah, I totally get that.
Yeah.
I had a career that was intersected in and out of the air cargo industry, and I understand how critical that supply chain is. There was always a fact we talked about where it was something like air cargo only carries 4 or 5% of goods, but in the end, it carries goods that have a value of over 30%. So it's for the most expensive and time critical cargo.
One of the coolest things I've ever seen loaded onto an airplane. This was 3 or 4 years ago. I was still with IBM. I was flying, for whatever reason, I was flying Stuttgart to Atlanta. Right. I know I was in Stuttgart because IBM's German headquarters are just south of Stuttgart. And I was doing some work with my team there. And I must not have been going home because otherwise I wouldn't have been flying to Atlanta. So I was sitting in business class on a 767-300 on the starboard side, right on top of over the cargo door. And I got to see the ground agents load a fully decked out, racing equipped Porsche, like GT3.
Okay.
With this huge spoiler, right? Lifted into the cargo of the 767. I thought that was amazing. I still have pictures of that.
Yeah, and I can hear the announcement. With the passenger who brought the Porsche on board, please come to baggage claim to collect it. You'd have half the airline there.
Yeah.
But on that note, Mark, I want to thank you so much for joining me on Thinking Through Autonomy. It has been an absolute treat, and I'd really love to have you back again.
Love to be back, Ken. It was a pleasure, and thank you for having me. This was absolutely fun, and happy to come back whenever you holler.
Thank you.